And now I'm excited to introduce Matt Welsh here for a talk on building applications using large language models. Matt is the co-founder and CEO of Fixie.ai, a startup developing a new computing platform for AI-based applications. Previously, he was Senior Vice President of Engineering at OctoML, and he spent time at Apple and Google, and as a professor at Harvard. And he's also the co-author of one of the first O'Reilly books I ever bought, Running Linux. So really happy to have you here, Matt. Go ahead, take it away.
All right, thanks a bunch for having me. Yeah, it was, maybe almost 30 years ago that I wrote my first O'Reilly book. I guess it was also my only O'Reilly book, but it was the best O'Reilly book. So once you've written one, you're pretty much done. Today, what I'd like to do is talk to you a little bit. I mean, Malte's talk was a great overview of some of the challenges around building applications that use large language models. What we're doing at Fixie is building on top of some of those same ideas, but also enabling people to connect their own applications using LLMs with their own data, and not just static data, but also live data coming from things like APIs, as well as using the language model to drive application logic. And so we're seeing a lot of interesting potential applications here. So I think everyone here is probably freaking out about ChatGPT and these technologies. This guy in particular, he should be freaking out that he's using a cell phone from 1997, I suppose. But I think one of the reasons that the world is kind of going crazy around this tech stack right now is that these large language models are a bit like an alien technology that just landed in our backyard. And we're just figuring out now how to make the best use of it. It's not like we've seen this very slow, gradual improvement in natural language models over the course of years, and now they're just starting to get fairly good. This transformation has kind of happened overnight. And, this would be as if, computer graphics went, in the span of something like 6 months from, having the quality of Pong to, Red Dead Redemption 2. And so I think this is the reason that most of the world is going a little bit crazy here. So the interesting thing about large language models is that you can think of them like a virtual machine that you can program in English. And this is a really interesting characteristic of these models. The interesting thing about it, one interesting aspect, is this was been discovered empirically. That is, that large language models were not previously known to have a kind of reasoning ability. In fact, they were, designed to autocomplete text. And then, people were discovering empirically that you could actually get the language model to follow instructions and to take a complex problem statement and break it into steps and then execute those steps one at a time, and manipulating a kind of world model as the execution proceeds. Let me show you an example of how that might work. When you program a large language model as a virtual machine, you can effectively teach the language model a new trick on the fly. If you've seen the movie The Matrix, it's like that scene where, they need to learn how to fly the helicopter all of a sudden, and all of a sudden they've learned how to fly a helicopter. So by sending the model a small number of examples of a task that you want to perform, you can teach it a new trick. You can say, in this case, I'm going to teach the language model how to look up stock prices and how to answer questions about stock prices. And in this case, what I'll do is I'll say, what is the current stock price for Apple? And instruct the model that what it needs to do is call some external function to actually get the data that it needs, because the language model does not know internally what the stock price is. But assuming that the model can do that and it gets back a response from that function, then the share price can be shared back as part of the response. And so the missing piece here is the ability to connect the language model to some external API or data source. And this turns out to be quite easy to do. And it turns out to be an extremely powerful abstraction for building new software systems. So where I kind of think a lot of this is going to be going in the future is we are going to start treating large language models like a new kind of computational substrate. That is, the language model itself is the code. That is, we're not using the language model to generate code and then compiling the code and running it on the machine, but think of the language model as the machine that you're programming. But you're programming it by teaching it a new skill in English. And so you're teaching the language model how to interface to an API, maybe how to pull data from a database, how to transform data in certain ways, and also potentially how to use software that was originally meant for humans. And we've seen some really interesting demos and products built up around this idea of interconnecting the language model to conventional software systems. And this is the reason that I think the industry is going berserk around these ideas right now, is primarily because this is such a powerful and new way of instructing machines that it's having a dramatic impact on our entire industry. Okay, so the question is, how do we get all these things? How do we get there, right? Today, you could start by going and grabbing an API key from OpenAI and starting to feed prompts into a model and getting back responses, and then you need to do something with those responses. But this turns out to be a very cumbersome, very low-level way of doing things. And where we see the world going is kind of a new programming abstraction that's built up around all of these ideas. So say you've got an amazing large language model app that you want to build. How do you do it today? Well, the first thing that you need to do is figure out which model you want to work with. And today, of course, most people are using OpenAI's models. But, there's also Anthropic's models, and there's some open source models like Llama and Alpaca, and there's Google is coming out with its models, and other companies are coming out with theirs. I actually expect that there will be potentially hundreds of open source large language models that are competitive with today's GPT-4 model in the not too distant future, because the technology for training these models and the data sets that you need are becoming much more widely available. So you got to figure out which model you want to use. Okay, then of course you've got to build connections between your application and the model and whatever data sources you want to interface with, whether it's databases, web pages, S3 buckets, external APIs. And Malte's talk showed examples of how to do that. But then, of course, you've got all of the, let's say, fun cloud crap to deal with. And what I mean by that is, where are you hosting all of this logic? How are you interconnecting all these pieces together? Many of these things require specialized infrastructure like a vector database like Weaviate or Pinecone. Of course, you need to have your monitoring, your testing, your evaluation, your authentication. All of these things need to be built up in order to use this stuff in a production environment. So I hope that I'm kind of setting this up for you is, of course, Matt, isn't there a better way? And this is maybe where this talk takes a left turn and sounds a little more like an infomercial. But I do want to show you how we're thinking about this at Fixie, because this is an example of how I think the platform for building large language models is going to evolve in the future. We have a particular way of thinking about this at Fixie, but we're also seeing plenty of other open source projects and commercial companies building out their own kind of platform. So the idea with Fixie is this is a cloud-hosted service. It integrates all of the pieces you need to build large language model applications. And in particular, it incorporates a wide range of models under the hood, as well as all the cloud infrastructure pieces that I mentioned earlier. And the key idea in Fixie is that you build what we call agents, where an agent is a large language model plus a little bit of code that knows how to talk to some external system. So for example, a database agent would go from English queries to SQL queries and fetch data from a database. The GitHub agent would go from English to the GitHub API and fetch information about your pull requests or issues or whatnot. And our idea is that as you build these agents, first of all, the agents are super easy to build. As I showed you just a few slides ago, the idea of instructing the language model to do a new trick is not that hard. And once you plug these agents into the backplane, if you will, they can communicate completely with each other in English. And so the idea of building up an application becomes a matter of composing the abilities of these different agents that could be built by different people and even running in different places on the internet, and having them communicate with one another in English. I'm going to show you a quick example of what that might look like in a customer service context. So in this case, we have a user who's gone on to a website, and maybe there's a little chat widget on the website that they can type in a question. We've all seen these things pop up. So in this case, the user is saying, I ordered the wrong size T-shirt. I'd like to get one size larger. This ticket plus some other relevant context would flow into the Fixie platform. And Fixie, using the large language model, would figure out what are the sequence of steps that need to be taken in order to handle this particular ticket. Because it's a return ticket, or they're asking about an exchange. So in this instance, the ticket would flow through a set of agents that individually use the language model to do things like look up the customer's order history, check the stock to see if the T-shirt is still available, generate a return label by calling like the UPS APIs for that, and then finally drafting an email reply that could be sent back either directly to the customer or potentially reviewed by a human before it's sent out. This is just an example, and I think the important thing here is that the sequence of agents and the sequence of steps that are invoked really comes down to the specific input that was provided. And this is the kind of rich, powerful, symbolic manipulation that large language models are so good at. Another thing about Fixie is that we allow agents to process any kind of data or any kind of media. So it's not just text. Think about this a little bit like email attachments, where I can send you an email with a image in it or a PowerPoint deck, and you as a recipient of that email know how to deal with those attachments in most cases. So in this case, if we were to say, generate an image of a red panda and put it on top of the night sky, Fixie would build up a workflow that first generates the red panda image, second generates the night sky image, third uses a different agent to mask out the background of the red panda, and then a final agent that composites the two images together to give you the final result. And again, you're doing all of this directly in natural language, and the individual agents are executing those steps. So as far as, how do you build agents in Fixie? The key idea in Fixie is that you use a set of few-shot learning examples. Those were exactly those few shots that I showed earlier for the agent that generates stock prices. But then you simply augment it with a little bit of code that knows how to call out to some external API or access some external data. And the idea is that this is just so easy to do. Most developers can build an agent in something like 10 minutes. The GitHub agent that we've built took me something like 20 minutes to build. It's just incredibly easy to put these examples together and then just provide those little low-level function hooks that need to be invoked. The reason this ends up being interesting is we're leaning heavily on the language model to do the heavy lifting here, right? It's responsible for interpreting the query from the user and kind of transforming it into these underlying function calls. And that's what the language models are good at. So we're using that as much as we possibly can. Few people have asked on the chat here about LangChain, and a lot of people ask me this question, so I'll just address it here. LangChain is another way to build agents in Fixie. So LangChain is this fantastic library. It's in Python and TypeScript that let you build up large language model applications. Fixie supports it. We have a simpler model here for building agents, and we kind of think that LangChain is useful in the cases where you want to have full control over what's going on and have more sophisticated agent behaviors. But if you want to build simpler agents, then this approach here is pretty easy to do. The other thing we can do is build agents automatically without any real code. And in this case, I'm showing it as code, but you can pretty much think about this as just configuration. Here, what we're doing is we're providing a list of web pages, in this case, the Wikipedia articles about the TV show Silicon Valley. And now I have an agent that knows how to answer questions about Silicon Valley. So I could go to this agent without writing any additional code, just this configuration here, and ask questions about the TV show and what happened in it. What I'd like to do is just in a real few quick minutes here is just show a live demo of this working in action. And I want to emphasize that this is all very rough and ready, kind of early beta quality software. So you'll forgive me if things don't work as expected. So what we're looking at here is the Fixie developer dashboard. Keep in mind, Fixie is a platform. It's not a website. It is not, going to a different web page and chatting with Fixie instead of, say, ChatGPT. Instead, it's a set of APIs that you can integrate into your own application. But we do have this developer dashboard to make it really easy to experiment with it. And what you're going to see here is we have a bunch of agents that have been built that each of these agents knows how to talk to some different kind of system. For example, we have a pillow agent that invokes the Python pillow library for manipulating images. The Google Calendar agent can answer questions about your calendar and create events on your calendar. We have the stock agent that I mentioned earlier. And so what I can do is, pick any one of these agents that, I might want to talk to and get it to answer some questions for me. So in this case, I'm going to chat with the GitHub agent, and I'll say, how many issues are assigned to MD Welsh, which is my GitHub username. And what you should see here is Fixie is sending this query into the agent. The agent is converting that into a query against the GitHub API. In this case, we happen to be using a SQL database. It's not a database, a SQL interface to the GitHub API. So we convert the English to SQL. And then when we issue the query against GitHub, I get back the answer. There are 21 issues assigned to MD Welsh, which actually makes me nervous because I didn't know there were so many. And then I can say, show them to me. And when I do this, I'm sorry. This is the downside of doing demos live, is that we're changing things all the time, and sometimes things don't work as expected. Let me show you the version of this that I had done previously. And what I say here is, show them to me. And it says, okay, I will go and fetch the open issues assigned to MD Welsh and return them as a list. So this worked pretty well in this instance. So now we're going to come back and look at another example where what I might want to be doing here is fetching some data from the web and then visualizing it. So in this case, I said, make a pie chart of the top 10 countries by population. And Fixie takes in this query and it says, okay, the first thing I recognize is this is a multi-step task. I first need to find out what are the top 10 countries by population. And it sends that query into the router. The router in Fixie is responsible for deciding which agent should get the call and sends that into a search agent. The search agent gets the query, says, look up the top 10 countries by population, does a Google search for that information, and comes back with the list of each country, the top 10 countries and their relative populations. Then we send this data back up into the router and say the second step is to generate a pie chart from this data. We send down the data into the chart agent, and the chart agent generates a pie chart. next, if I were to say make a bar chart instead, in this case, I didn't say make a bar chart of the top 10 countries by population. The conversational context is present here, and therefore it's really, really easy to just understand that I mean to do exactly the same thing, but just using a bar chart instead. And so the final result is a bar chart. So I think this is just intended to show a little bit of the power of building out these individual agents, getting them communicating with one another in English, hopefully showing that it's really easy to do. And all these things are running in the cloud. So if this has gotten you excited, definitely head on over to our website. It's fixie.ai, and you can sign up for the developer preview. It's completely free to use. You can build agents, you can build client applications, you can interact with the existing agents in the system, and everything that I just showed you should be working. Okay, so takeaways here. Basically, we're just looking at large language models as this new kind of computational engine. And what we're seeing is that it's still pretty hard to tap into their abilities. There's a lot of machinery that you need to build up. But once you build up that machinery, we think that it becomes extremely compelling to start replacing conventional software with this concept of natural language agents. And so, my general message is if you haven't been freaking out yet, now might be a pretty good time to start. So with that, thank you very much. And if we have time for questions, I'm happy to answer any questions.
Thanks, Matt. We've got time for one question, which has come up quite a bit here in the Q&A. And it's about testing. Obviously, with the current error rates of large language models now, how are you going to test the applications that you would build with Fixie?
Yes, exactly. And I think, Malte's talk earlier also spoke to that. I think that my expectation is that any company, any platform, any system that's building around large language models is going to have a solution for quality evaluation and testing. With Fixie, the way that we're thinking about that is, first of all, you can effectively unit test the individual agents. And that's really helpful because an agent itself is fairly constrained in what it should be allowed to do and what kind of answers it's going to give you. And now you need, at a second level above that kind of rigorous unit testing of one agent, you need to be able to have the same kind of integration testing, make sure that multiple agents are going to work together effectively. This is obviously an ongoing area of research for us and for many others. And so we are integrating a lot of capabilities into the Fixie platform to make that super easy and automated, but this is going to evolve a lot over time.
Just like anything else in this space, it sounds like.
It's moving fast.
It sure is. Thanks very much for spending some time with us today. Great presentation. Really appreciate it.
Thank you.